PAP chemistry students. We're here to learn about type 2 ionic compounds, or how to name them. So our naming rules for these, we learned that type 2 compounds had more than one oxidation state. So that would be looking at these guys right here. The type 2 are these mostly transition metals. They have variable oxidation states. So like chromium, and then manganese, iron, cobalt, copper, tin, lead, and mercury. And there are all of these in here are type 2, but these are the most common ones, and these are the ones you'll find. So we have a different naming rule for those. Naming type 2 is we're going to use Roman numerals, and I'll explain what that is in a second. Since we could have different ones, you can't just say copper. You can't just say copper. You have to say copper 1 or copper 2. Okay, so we use a Roman numeral for that. The Roman numeral is called the oxidation number, not the oxidation state. It's the oxidation number. So that's a fun little quirk. So if we check them out down here, we will see that C and D are type 2, and then B and D down here are type 2. So what this is doing is you are adding this oxidation number right here. Now what that's telling you is that that is what the oxidation state is. So lead 2 fluoride, well, that's going to be a positive 2. Okay? And then fluorine is a -1 charge. You look that up on your chart. So we find that lead 2 fluoride, so that's going to be Pb with a 2 plus charge, and then F with a -1 charge. That's not the answer. We take the 2 and we cross the number only, and we put the number down here. So let me rewrite it. We're going to put a 2 down here, and we take this number, number 1, and we cross it, and we make it the new subscript on the other one. So PbF2 is lead 2 fluoride. Okay, so so you don't get distracted, that's not it. Now copper 1 sulfide, that's going to be +1, and then sulfur is going to be -2. So it should be copper is Cu, and that's a plus charge, or +1 charge, and then sulfur is a 2- charge. So this 2 comes down here, and the 1 comes down here. So 1 goes down here. So that is going to be Cu2S. So that doesn't really change too much with the type 1 or type 2. You are simply just taking the charge that is given to you right here. And it will always just be given to you because that's the right way to write the name. However, when you have to write the Roman numeral, it's a little strange. So let's do just a couple more where we're taking the name and turning them into the chemical formula. If we have lead 4 chloride, that's going to be Pb4 plus. Okay, because Pb is lead. And then chlorine, we know from our chart, is a minus charge. So this number will come down to the new subscript, and this number will come down to this new subscript. And so we'll get Pb. That number is a 1. So its number is a 1. It's understood. I won't write it. So I'll write Cl, and its subscript is a 4 because that came from the lead. If you really think about it, think that there's 4 positive charge, and this is a -1 charge. So you need 4 chlorines to cancel out this +4. We're trying to get a net charge of 0. We want a net charge of 0. Okay, that's what we're looking for. We want to cancel out the positives and the negatives so that their net charge of the whole molecule is 0. We look at cobalt 3 oxide. That's going to be CO, 3 plus, and then the O, 2 minus. So that 3 comes down here, and the 2 comes down here. So we get CO2O3. All right. So if you're noticing, don't ever just drop the charges straight down. You'll always get it wrong. Now, for lead oxide, it's going to be great. We also have another lead oxide. So, we have a couple options right here. Because lead is a 2 plus, and then it's also a 4 plus. So we're going to say that this is lead, and we're going to write Roman numerals, and we're going to say oxide. And so now we have to use some deductive reasoning here. We know that oxygen is a negative charge, and we know that it's a 2 minus charge, or a negative 2 charge. So that means that we had lead here. So we're doing kind of a reverse crisscross right here. Instead, like normally you would have had a 2 to come down here. So what charge would you have had to come down here? You're right, it would be a 2 plus, because the 2 plus and the 2 minus should have canceled out to make PbO. So that would be lead 2 oxide. Now you might be saying, well, why isn't it Pb2O2? That's not correct because the 2's cancel out. So that should be just PbO. Now, for this guy, another lead oxide. Lead is, again, Pb. So let's write Pb, and let's write O, and then oxygen had a 2 minus charge. So that means that we had a 2 minus charge, and there were 2 of them. So 2 times 2 minus is an overall charge of minus 4, right? Overall charge of minus 4. So to cancel out, we only had one lead, so to cancel out the minus 4 charge, this one must be a 4 plus, or a positive 4. Okay? So lead is a 4. That's lead 4 oxide. Try a couple more. We have SnBr2. Well, that is 10 something bromide. I'm sure you'd be able to find it on the periodic table. Now, 10 is Sn. So that would have been Sn and then Br. Now we know that there were 2 bromines, and we know that bromine is a minus 1 charge. So there were 2 minus 1 charges, so that's a minus 2 overall. Overall, that's a minus 2. Then that means that this guy has to be, we only had one of them, so 1 times what number is 2, right? It's be 2 plus. See how that works? So 10 is going to be 10,2 bromide. And now Cu3n. We have copper, parentheses, nitride. So now copper is Cu, and we all had 3 of them, and then we have nitrogen, and we only had 1 of them. So nitrogen is a 3 minus charge. So we had 3 minus charges, so that makes it an overall charge of minus 3. That means that this guy has to be a positive 3 over here. So 3 times what number is positive 3? You're right, it's a positive 1, right? So the charge of copper is +1. So, so that's copper 1 nitride. Hopefully that works out. Let's take a look at your notes right here, and let's make sure we get this correct. Go ahead and pause and try these two right now. Okay, welcome back. We've got nickel, 2 oxide. That's because nickel was and oxygen's a 2 minus, so we need a 2 plus charge to cancel out that oxygen. And then this one would be lead, 4 sulfide. That's because lead is Pb, and then sulfur is a 2 minus charge. We had 2 of them. That has an overall charge of -4, so that guy must be a +4. So, +4. All right, have a good day. Enjoy your homework.